In this video, I'll be talking about how to route on-premise and spoke traffic through the hub within the Azure public cloud environment using the Azure Firewall as the DMZ, which manages the inbound and the outbound traffic between and outside of the hub and between and outside of the on-prem and the spoke vnet. So first of all, we will be creating a resource group, just a separate resource group for this. So I'll just call it secure hybrid. Sorry, I'm just making this up on the fly. Secure hybrid cloud resource group. Okay, so I'll be using East US, or which other location should I use? Let me use Europe. Okay, so this should only take a few minutes. Then I will be creating 3 virtual network: on-prem, spoke, and the hub vnet. But I will be going in this order: hub, spoke, and on-prem. So I'll be hub for hub vnet. I'm just opening different tabs for that purpose. Hub vnet, spoke vnet, and on-prem vnet. So let me show you the architecture I have in mind. So this is an on-prem. It's just a fictitious on-prem. Everything will be based in Azure, but this is what is likely to happen if you have your data center that is outside of the Azure public cloud. You have it, but because we are doing it within the Azure environment, but this is how it will normally be. You have your physical data center, maybe somewhere in a co-location data center, or somewhere within your premises, and you have your vnet within vnet for your hub and your spoke vnet as well within your Azure. They can be within the same resource group or at separate or different resource groups, but in this case I'm using one resource group for everything, actually for all of them. So that's what I'm doing, and let's try and move on. Hopefully we'll understand it as we progress. So these are the CIDR blocks that I'm using for them. For the on-premise, I'm using 192.168. For the hub vnet, I'm using the 10.0.0.0.16. For the spoke vnet, I'm using 172.16.0.0. So let's see how quickly we can get this done. So I've just created this resource group for this purpose. So this, I'm going to name it. So I'm starting with the I've got some instruction here. It's somewhat step by step, but I will attach a documentation that will tell you like almost line by line activities that you need to do. So this is just a guide. So vnet hub. So I'll be using the IP address CIDR for the hub. I actually think I'm using something different, but I can use what I've put there anyway. So 10 dot. Then I'm calling this, what did I say here? So this is for the firewall, Azure Firewall Subnet, because this is where the firewall will be hosted. So 10.1.0.0/26. So the CIDR block for the firewall is relatively small. That's why I'm using .26 for that rather than .24. So 26 means you can have about 59, generally about 64 IP addresses, but as you can see, 5 of them are reserved. So I'm having 59 IP addresses that can be used for other things within the Azure Firewall Subnet. So we do not need any of these resources right now, NAT gateway and other services. So I'm just creating that. And this doesn't take too long a time. Then I'm creating the spoke. So this will be vnet spoke. Then the IP address I'm using for the spoke is, as you can see on the screen, I hope you can, I'm using the 172 CIDR 160.0.0/16. Oh, sorry. Then I'm creating a workload subnet. Then I'm calling it 172.16.0.0/24. You see for the hub subnet, the workload subnet within the hub vnet, for the firewall subnet I meant, so I used /26, but here I'm using /24. So you can see it gives me more opportunity for spare IP addresses, 251 IP addresses that I can use for other things here. Then I'm doing for the on-prem. So for this I'm using a different CIDR 192.168.0.0/24/16. Then here I'm doing 2 subnets. I'm doing one workload subnet. Should I call it I think it's fine, but just to be sure, so let me say on-prem workload subnet. So I can do the CIDR for this 168.1.0/24. Then I can do a gateway for this, so just call it on-prem gateway, maybe on-prem, no, gateway subnet. So 192.168.2.0/24, and I'll go ahead and review and then create. So what I can do next is to launch a firewall so which I can retrieve from the marketplace within the search. So I'm going to open that. I want to quickly open the virtual network gateways as well. So VPN, virtual network gateways, that I'm going to use for the on-prem, just making it feel like it's a real physical location rather than in the cloud, for the on-prem at least. And I will be doing creating one virtual network gateway as well for the hub. So let's create a firewall. The firewall takes a few minutes to deploy, it takes up to 15 minutes. I'm not really trying to time it, but yeah, it could take up to that, potentially longer than that, but it's about 15 minutes. So let's create it and hopefully we find out how long it takes. So what shall we name this as? Azure Firewall 01. So the location, let's just locate it in the same location as we have been, so which is West Europe. So let me just try and type it. West Europe. So let's leave the availability zone. So one of the things we want to do is that we're using the standard firewall. We're not using the premium. And like I said here, we want to use the policy to define our rules here, our rule collections. So we create a firewall policy. So Azure Firewall 01, I just call it policy. We can write everything policy. So the same location, no. So let's just be consistent and keep it to West Europe as well. And what I want now is to provide the virtual network name that this is going to be attached to. As we can see in our diagram, this will be attached to the hub vnet, even though the IP address allocation is a bit different, if you remember initially, but we're still going to get to the same conclusion. So I'll be providing a private IP address, public IP address, I should say. So this is going to be assigned to the public IP address that will be allocated to the firewall. So what else do I need to do? So in this case, we are not doing any force tunneling, so everything is going to be as it is. Validation has passed, so I can create. Then I go ahead to create the virtual network gateways as well. So I'll first of all be creating that of the hub, because I'll be having a virtual private gateway on the hub side and on the on-premise side. So this is for the hub. So shall I call it VPN hub? So let me use the same, just being consistent, West Europe. Then so before I get here, so we are, like I said, we're using a VPN. We're not using express route, we're using a route based VPN type, not policy based. Then I'm just going to change this to basic, because this is just for demonstration purpose, nothing much here. So this is going to be attached to the hub. And what else do I need to do? Then I need to provide a public IP address as well for the VPN interfaces that will be attached to the on-premise side and to the ops side as well. So I can call this VPN hub PIP public private address, public IP address, right? Okay, so this will take a few moments. So I might be pausing intermittently just to allow this to be created and be ready so that I can progress, because sometimes you cannot really go ahead and be doing other things. But whatever I can do while we're waiting, I will try. But just in case I may need to pause every now and again, just beware. So this is creating another virtual private network, which is called a virtual network gateway for the on-prem in this case. So I call it VPN on-prem. So I use the same region. Then it's still a VPN. I'm using a route-based VPN type. Then I'm making this a basic SKU. Then this is going to be attached to the on-prem. As you can see, because I've already associated one to the hub, it is no more available. So I only have the on-prem and the spoke available to be associated to. So, and I'm associating it to the VPN, to the on-prem in this case. So I'm going to create, so this is to the on-prem, and automatically is assigned it to the gateway available, gateway subnet for the on-prem. So I will be creating a public IP address name. So I'll be calling it VPN on-prem PIP, right? We don't need any of these for our demonstration. In other purposes, for other use cases, yeah, we might need to configure or enable this. But in this case, we don't really need to. So you can enable active mode so that if one fails, they can both be running simultaneously, and the BGP configuration as well. Okay, so this is done. So the other things I can do now, let's look based on our instruction. Like I said, this VPN can take up to 45 minutes. So what else can I be doing while we're waiting? So one of the things we can be doing is, what we cannot really do now is, until these network gateways or virtual private network configurations are available, we cannot connect anything. So we need to wait for this before we go ahead, and we cannot really even do the vnet pairing between the hub and the spoke at this time, because it's relying on some of the configurations that we are doing with the VPN gateways that we are creating. So as a result of that, we may not be able to do any pairing connection between the hub and the spoke, even though you might want to think you can, but really speaking, you need to wait for the VPN connections to be done before your vnet pairing can actually happen, because of what we're trying to achieve here. So one of the things I can do right away is to create my virtual machines inside the on-prem and the spoke. So I think I can do those two while we're waiting for this, because this, like I said, will take quite a long time. So hopefully we have some time to do that. You'll see how long this would take to create. It started at 12:22, but we can probably see how long it would take to finish. So let's launch some virtual machines. So I'll be opening 2 tabs for virtual machines. So one virtual machine for, so a virtual machine for the because where we really, if you look at our diagram here, we really want to test connectivity between these two locations, between the spoke and the on-prem, for outbound and for inbound between the two of them, and even for the spoke as well to be able to gain access to the internet. So that's what we also want to achieve. Maybe one thing I could have done is I could have put just an arrow here, but it's both two-sided arrow, so it comes in and it goes out as well. So the spoke can outbound and it can also accept inbound traffic. So you can see the arrow is pointing both ways. So that's what we can do while we wait for the VPN configurations to deploy, and the firewall as well to be ready. So let's go ahead and do this. So for this, I will be creating a Linux instance. If we have time, I will be doing probably a Windows as well if we have time, but I think just to be, yeah, so I'll see what I can do, if I can actually do both. Not because I cannot physically do it, but because of the time I'm trying to spend on the recording, and definitely just to make sure I manage the consumption of the resources as well. So the resource group we are using is the hybrid resource group. So this is my spoke VM. So we're in the West Europe region. Then I'm using Ubuntu. Then I can stick to this virtual machine. Then I'm using Linux is quite case sensitive even with your username, so I'm doing all lower cases. So here, this is for the spoke, so I'm using, because I would like to make this virtual machine also a web server, so I'll be enabling both of these protocols, the HTTP and HTTPS, and as well as access to make changes and do some configurations in there as well. What else? I think that's it. So for the disk, I'll be going for a relatively, hopefully cheaper standard SSD. So this will be attached to the spoke, if you remember. So to be attached to the spoke, that's why we name it. And this spoke, we do not want it to have a public IP address, because we only want it to have private IP address, because there are a few use cases while this would be the case where you do not want you have several regulatory requirements, including the personally identifiable information access control as required by General Data Protection Regulation GDPR, or the Privacy Shield before that as well, and other regulatory requirement. Maybe this is in the health sector, maybe the EPA requirement, or the financial service requirement, including the PCI DSS requirement that you need to manage the information of your cardholders and stuff. So you want them to be relatively protected as part of your layer defenses or defense in-depth mechanism or defense in-depth architecture that you have in place. So as a result of that, I'm having no public IP address for this, and the network security group, which I've already sort of created with all these inbound access, HTTP, HTTPS, and 22. Then just for the demonstration, I'll be disabling boot diagnostics, because we don't really need that for this, and we don't need any of this configuration here as well for this demonstration. So as you can see, our virtual machine is ready. So what we can do is to actually try to access the virtual machine. So let's go to the networking. So you can see the IP address. So let's try and access this first of all, which in theory should be straightforward. So I'll look for a POTI, which I'll bring to your window. So like I said, this is Azure user, and I created a password for it. So now I have access to this. Can I see if I have access to, in theory, I know the IP address that will be allocated to the spoke machine, the spoke VM, but I would like you to just see. So I think it should be 172.168.0.5, no, .0.4. So that will be the first IP address that will be allocated to it. So let's have a quick look. Is the public, so .0.4. So but I just wanted you to see that. Okay, so let's try and access it from here as well. So this is we're using the POTI client, so SSH. So we're using Azure user, and the IP address 172.116.0.4, which, because we've not done anything at this point, we've not done peering connection, we've not done our VPN gateway connection, so there is really no connectivity between these two subnets at this point. That's why we cannot connect right now. So we are still waiting for this to be ready. Like I told you, it takes about 45 minutes. So in theory, this should run up until about 1 o'clock, about 1300 hours at least. But sometimes it's actually quicker. But I'm just saying, all things being equal, it shouldn't probably take longer than 45 minutes. I've done it in between 25 and 30 minutes in the past, so I won't be surprised if this happens as well. So, and this one as well, this started at 20 past, so this one will probably be ready before this, something's been equal. So I'll be pausing this recording right now while we wait for this deployment to conclude, the virtual network gateway deployment. So I'll see you in a second. So as we can see, one of the gateways is ready, and I believe the other one will soon follow suit. So this took about 30 minutes. So hopefully this does just about the same thing. So now what we need to do is to create a connection between the on-prem, the hub, and the on-prem VPN. So I create a connection. So I can call this hub to on-prem. Then this is from the hub and to the network gateway, which is the on-prem. And I'm creating a pre-shared key. So pre-shared key basically is like an encryption key that we use for the connection between the two of them. If they are not exactly the same, there is not going to be any communication between the two. So I'm going to use a relatively short one, but you can create a random shared key that you can provide for both ends of the connection. But I'm just creating a relatively ABCDE 1 2 3 4 5, so which I'm going to use during the other connection communication creation as well. So this is really easy. So hopefully once that is done, oh sorry, we're not there yet. So this is created, then I'll create for this as well. So this is also ready. So it probably took just about half an hour as well. So I'm creating a connection. So I've already created one, which is still updating, waiting for this to be created, for the second hand to be created, which is on-prem to hub connection. So this is from the on-prem end, and the other hand will be the hub in this case. So I'm including the exact pre-shared key. So as you can see, a mixture of lectures, they're just advising us on what to do, so to establish encryption between both environments. In this case, we're not using APIPA, which is the private IP address. We're not enabling BGP in this case because this is just a test configuration. So while this is done, this is between hub and on-prem. And if you remember, the connection I'm trying to establish here is between my on-prem virtual machine to my spoke. For the moment, I've not done anything different. There is really no connection between on-prem and my spoke here. And to make that happen, to make like, if we just kind of step back a bit, so we've just created a VPN connection between these two environments. At this point in time, there is really no way any traffic can come from on-prem to the spoke at this point in time. The only way that can happen is once there is a connection, a peering connection between the hub and the spoke, which will be doing right away. So that means there will be like some form of transitive connection between the on-prem and the spoke. But so just to show you practically what this means, my connection, an SSH connection to the spoke VM will still not go through. And one way to go through is once I'm able to establish a vnet pairing. So a vnet pairing between my hub and my spoke. Vnet pairing between hub and spoke. As you can see, vnet pairing. So that's what I need to quickly do now. So I go to pairing. So and I add that. So this will be hub to spoke. This is pairing. This is not, it's similar to VPN connection anyway, but this is like pairing. This is what you do, because there are several ways you can have connection between your vnet or other private environment or private cloud you might have before, but this is one of it. If you are using your hub and spoke within an Azure environment, you use what we call peering connection. So if you have a physical data center or a co-location data center or a data center that is hosted in your physical on-premise, your office block, your corporate head office or stuff, you will be using a VPN gateway connection to establish that connection. So it's just similar thing, but just the nomenclature is a bit different. So I'll be calling this a spoke to on-prem. So it spoke to hub. So in this case, my virtual network here is the spoke, because my source is the hub and the target is the spoke here. So because I've already created my VPN connection, so my virtual network gateway for my hub would be using this one, and so from the hub it will be use this virtual network gateway. We are not using a root server in this case, but here I'll be using the remote end of it. So use the remote virtual network gateway. This is what I'll be using for the spoke. So he's making use of the remote. So whereas the vnet is using the main rather than the remote, the source. So that's what this is. And once this is established, like I said, this might take a few minutes. I would like to think maybe about 5 minutes. I've not really timed it. I've not really been focused on timing it, but I think it takes just about 5 minutes to do that. So one way we can actually be testing it as well is to actually establish a ping. So if I ask it to ping, which is 172.168.16.0.4, you can see there is refresh it, you see that it's already connected. That's why this is happening. And one of the reasons why this is happening is that if you see one of the rows here, it allows all vnet inbound access from any virtual network. You can see it allows any form of access, including ping. So that's why this is happening right now. So this is done, and what I would like to do is I would like to stop. So I believe there is connection. So there is some form of transitive connection between the on-prem and the spoke. That's why the private end of the on-prem can actually ping the private IP. If you remember, this does not have a public IP at all. You can see it has no public IP, whereas my on-prem has a public IP. My on-prem, you can see it has a public IP and a private IP. So I'll be pausing this. So if I look for the ifconfig, I need to update the net tools, okay, which I'm not doing here. So now I will be able to log into, connect to the spoke VM. So I'll be able to connect to it. So because it's asking me to progress, whereas it never did before. So, and I know the password. So as you can see, this is working now. I have access to the Spoke VM, as you can see. So I've been able to move from the on-prem to the Spoke. I've been able to do that. So what I need to do now is to actually make this Spoke a web instance so that it can serve like a web server. So to do that, so I'm just updating it first of all. Then I will be installing an Apache web configuration on it. So sorry, I think so this should only take like few seconds. So as I mentioned before, so what we're trying to do is to be able to control the access to this VM and even this on-prem as well, inbound and outbound access of both of them through this firewall in the hub vnet. That's what we are trying to achieve. So for the moment, that is not been done because I am yet to configure the firewall for that purpose. So now I will be logging out from so let me try and call 172.16.0.4. So you can see it's serving as a web server on its own. So this is the kind of interface you have. So yeah, because I cannot really demonstrate for you from my laptop straight away, trying to access it from a Windows, but this is the kind of interface you have from outside. I'll see if I can create a Windows in the on-prem vnet, like your on-prem anyway, but in this demonstration is a vnet, is a virtual network. So but I'll see if I can quickly demonstrate that as well. Okay, so I'm out. So what I want to do now is, I've already demonstrated pinging, right? So if you remember, so I can ping it, so which is okay. So what I want to do now is I want to create I've already deployed this firewall, but I want to configure the policy to allow all these rules here, all these ports to be allowed within the firewall. So that's what I would like to do next. So the firewall has already been created. So I'll create what they call a network rule connection. a network rule collection, right? So that's what I will do, and I'll be including all those ports that I would like to add. So one way I can do that is I'll continue to ping this, and at a point you'll realize the ping will stop and it will commence once we ask it to. So once I define the rule and I do the association, there should be some changes. So I'll call this rule collection 01. So I'll call it this. So what we're doing is we are doing for, so let's do for 22. So let's just say SSH. So the source, as you can see, our source will be the vnet, and our destination will be the on-prem vnet, and our destination will be the spoke vnet. So I'll say 192.168. Oh, this is a point, right? Okay, I think it is. I think I use 0.0/24, and I like a TCP. Then the destination we're talking about is 22, and the destination type is also an IP. So I'm using 172.16.0.0/. I can actually make it the entire space, or even limit it to just to this subnet here. So I can use RDP as well, because like I said, it could be a Windows. This is for Linux instance, while this will be for a Windows instance. So 192.168.0.0/24 to a TCP to 3389. That's the port number for RDP, to 192.168.0.0/24. So let's do for the web service that we've just created as well. HTTP, so which is from 192.168.0.0/24. So it's still a TCP.80 to 172.16.0.0/24. So the other thing is HTTPS, HTTPS. So from 192.168.0.0/24 to a TCP as well, 443, and to 172. I keep missing that. .16.0.0/24. All right, so the last one I would like to add would be the ping. So ping from 192.168.0.0/24. Then I would like to add a ping, and I'll call it 1, because I think 0 is not allowed here. Then 172.16.0.0/24. All right, so let's see. So it's saying, did I include something that is not? Oh, sorry, this should be a slash. All right, so I think this is one step that we've done right now. And before this can really take effect, we need to do what we call an association. Because we've created its policy right now, it's not being associated to a particular subnet or a particular network. So, and maybe I can demonstrate that to you by just holding on for a few seconds. Maybe I can pause it while I wait for this to conclude. You can see, once you see this that keeps moving and progressing, it means the assignments or the rule that is just created or anything that you are doing, it's not complete or it's not ready. So once it's ready, you'll see all the rules that we've just configured will be displayed here. So for the moment, that is yet to happen. So what I can do is I can just pause my recording for a few seconds. Yeah, so here we are. While I was waiting for this firewall to the policy to be ready, I've quickly gone to create a VM, a Windows VM, just instead of having a Linux VM, to demonstrate the web instance that we have. I'll hand this one quickly. The instance that we have, I don't know if I did, or maybe I did not. So we can create a call for the IP address in the spoke, and you can see there is a virtual there is a web instance, Apache web instance on the spoke VM. So I'm doing the same thing from a Windows, from the same vnet as this. So from the on-prem vnet. So sorry. So the IP address is 172.16.0.4, just as it is here. And you can see it has access to the Ubuntu default web page. Yeah, so it's exactly the same information as we have here. So in Linux and in Windows, in the GUI interface. So what I want to do is, and I believe I can do the pinging as well, just similar to what we have here. So let's continue the pinging, and let's be doing the pinging from here as well. So let me do it from here. Where is my, do I have it? Yeah, my PowerShell. So ping 172.16.0.4 continuous ping. So what I want to do now is I want to create, you can see even once I've added this firewall rule, the rule collection, once I've added it, all the traffic is still going through the connection and through the, it's still going through the connection and through the pairing connection and through the VPN connection, not through this this virtual instance at this point. So, and I would like to change that right now. And what I need to do is to create what we call route. So I'm creating route table to change that. So I'm creating two route tables. So one route table, so there is one. We don't need this for this demonstration, but I'll create another one. So I'll just call this, I'll call it, so this will be associated to our resource group, and let's keep it simple as well. It's going to be associated to our West Europe region. So let's call this a UDR. What we call UDR is a user defined route. So because we are the one defining this by ourselves, because we want to force it to take precedence over the ones created by the NSG, Network Security Group. So we want to force that to come via the Azure Firewall. So that's why we call it a UDR, user defined group, user defined rule. I hope I mentioned that here. I believe I did, right? Maybe it's here. So I've created a policy, then this is it, user defined route, right? So I'm creating that. So I'll call this, what shall I call this? Let me just call it, so user defined route for the, let me just call it hub and spoke, right? So I'll leave this one to propagate, because, so my reason for it to propagate is because this is hosted, so to prevent the propagation of on-premise route to the network interface. So I'll leave this to propagate in this particular route table. Then I'll create the second one. So this is another user defined route. So let's just call this. I'll ask this one not to propagate. So what I'll do here is, now I can do what we call route. I'll create the real route that I really want to enforce on this to happen here, how I want to enforce it. So what I want is, I want this vnet to be able to access the internet, but I want it to access the internet. If you remember, this virtual network, the virtual machine in the on-prem already has a public IP address, but if you remember, this does not, right? But I want to force this traffic to access through here in this case. So that's why I will create what they call the route name. So you can call it anything. So we can call it internet access. So we can say internet access or spoke. But spoke to hub, or is it up to spoke? So this will be to the, so this will be to the, so this will be to the spoke IP address range. So that will be 172.16.0.0. Let's use the entire address space in this case. And we are using the virtual appliance that we've created in this case, which is the firewall. So we're using the IP address, the private IP address, not the public, the private IP address of the firewall here. So which should be 10.0.0.4. I hope that is the case, but let's find out. So if you look at the firewall, you see 10.1.4. So yeah, because I didn't use the same IP as here, so 10.1.0.4, I think that's correct. So we go ahead and do the same thing. Yeah, so in this case, I'll need to associate it to the hub once I've created the route. So I'll associate it to the hub and to the gateway subnet here, rather than the firewall to the gateway. You see some things will slow down. Okay, so something will slow down. You see some form of timeout, or maybe something just trying to connect. That will happen. It will probably take a few minutes, but I don't know which one will happen first. But let's just keep having a look. I'm yet to associate the second bit. Let's give this a few seconds so that we can see which one actually changes the entire configuration or the entire path or the route the traffic actually takes. That could take between 2 and 5 minutes sometimes. So even though this is ready, maybe it's really ready or not, but nothing has changed, right? But I think it could take between 2 to 5 minutes if anything is going to change. So what did I say here? I said it could, I didn't put a time to it, so but I think it could take a few minutes for that to happen. All right, you can see it's beginning to time out now. It's beginning to time out, and this is now, at least Windows is telling us. You can see this as paused, right? So for it to continue now, that means the traffic is now being forced over the firewall as we want. Anyway, that's what we are trying to achieve. So we want the traffic to be forced over this hub vnet using the firewall and the firewall subnet, basically. So what I'll do now is I'll associate the other one to the internet, like we said. So I will associate it to the spoke in this case. So to the spoke and to the spoke workload. So this will take a few moments to take effect as well. As you can see, this has paused, right? It should kick in. The sequence, SMP sequence, should continue once I've okayed this. It takes between 2 to 5 minutes as well. So let's just try and wait it out a bit. So while we are waiting, so if I went back to, now we are trying ping. If I went back, let's try and use the Windows for instance. If I went back to the web site to try and access the web page, I shouldn't be able to to access it anymore except if it's cached. So which you can see I'm not able to access it right now. So that's why this is happening. But once the rule is updated, I think I should be able to ping and I should be able to access the page again. But let's see. I believe this has been 1 minute, maybe a bit longer. So hopefully this should start moving and counting very, very soon. And if it doesn't, we'll find out why it's not together. Maybe I should pause my recording while I'll try and estimate how long this took, but I'm thinking it should take between 2 and 5 minutes, but I'll try and pause it. I'll try and let you know once I come back, because I wanted you to see everything live and direct, as they say, but for the moment that is not what is happening. Something gonna change now? I would like to think yes. So as you can see, you can see from the firewall policies, defined my source IP. As you can see from some of them, I have 196.168.1.0/24, and for some of them I have 192.168.0.0, and that's why initially there was no ping there, even though the association I did was correct, but it was just because I misdefined the source IP and the source IP particularly. That's why. And if I show you an example quickly, so if I pause this now, because if you see my web service port, you'll still see I still got 0/192.168.0.0, but the IP address I actually need is 192.168.1.0. That's why it's highly likely that it's not going to succeed as well. So I'll pause this so that I show you that. Call this, you see that it wouldn't. Sorry, what was that? Yeah, so you said there is no rule match, because that is correct. There is no rule match because I did not define it correctly. So if I look at it from here as well and try to look for the web server, the Internet Explorer. So if I try to, should I just refresh? It's saying access denied as well, which is the same thing as there is no rule match basically. But once I update this web access, once I update it, I should be able to gain access to the web service on the spoke. And let's see how that goes. This will take a few moments to do. This will continue to ping because I'm not doing anything with the ping. I'm only doing something with the web access service. So let's see. Let's give it a few moments and see if anything. So if I just 172, you can see it's already sort of gotten access to the internet, but that's not really what I want. I just want it to be able to, even though it's gotten access to the internet, I believe. So that's what I was trying to achieve. Okay, but that's not what I'm trying to achieve. I'm trying to be able to access from the on-prem VM. I want to be able to access the web service on the spoke VM. So 172.16.0.4. I think that should be possible now anyway. So you can see it's possible, and here as well. So was he asking me? There is no rule match. So if I ask it to do it again now, you will see it went through. So just to recap, the purpose of our demonstration today is to demonstrate how you will be able to have some form of transitive access from your on-premise. Even though this is all done in Azure Cloud, it's the same thing you would do like physically if you have your co-located data center or your on-premise data center that is just within your office block or your office premises or something. You'll be able to still do exactly the same thing, be able to access the workload in the spoke. So maybe if you have an initiative or a policy that requires all your newly configured or newly deployed VMs or services to be hosted in the cloud, like forced cloud policy or forced cloud initiative. So that means everything from now on will be deployed in the cloud, and maybe you have like a regulatory bound instance or application that you like to launch in the cloud. This is one of the things you can do to create a VM instance that has no private IP, depending on the sensitivity or the privacy requirement or other regulatory requirements you might have for those instances. It could be database, it could be other application, and you can create them in a relatively private area of the cloud, and only allow access from on-prem user or from on-prem other services to be able to access this instance in the cloud, but going through your virtual instance, going through your vnet hub, as you may have configured your environment. So in this case, it's going through the vnet hub with the firewall device there, and everything goes in and out of the VM, which is mostly made possible by the rule set here. But on top of that, you need to assign it to the appropriate UDR. You need to define the appropriate UDR and associate it to the appropriate subnet of your environment. And that's what I have done here. And everything is now up and running. And you can do it for similar or different use cases. It could be a use case where even though you have something in the cloud, you want them to access stuff in the on-prem for whatever reason. Maybe you trust maybe you have even some governmental requirement that doesn't allow you to host or put some of these things in the cloud, that it has to be physically hosted because you sort of trust the way you used to provide your security layered security that you used to have in place before. So you trust it more than really kind of having those data sets or those database in the cloud. You can have it almost vice versa. Instead of having the address prefix to the on-prem, to the spoke, it could be the other way around in this case. And that's what you can also do, to make the spoke to be able to access like a database or something of you consider a relatively secure data classification in your environment, so that everything can be accessed from a remote location or from your spoke, as indicated by this design. So I hope this really kind of makes a lot of sense to you. I will be adding on, including some link that you may probably find more helpful, that will tell you not just the step by step, but other information that you may be able to read more, other than just straight to the point demonstration, even though I've tried to explain some of those use cases as I'm talking. But you may find more pointers from some of the links I'll be providing from Microsoft itself in this case, and from other contributors as well, outside of Microsoft. All right, thank you very much for watching, and hope to see you next. All the best. Bye.